We're given the graph of this function, f of x equals x squared plus 16 all over 3x, x not equal to 0 because then the function wouldn't be defined, and we're told there's a maximum point at a with coordinates a, b. Let's find the value of a and the value of b. So the fact that it's a maximum means it's going to be a stationary point. The gradient is going to be momentarily 0. Therefore, I'm going to work out what df by dx is. And I can use the quotient rule for this. U dash is equal to 2x, v dash is equal to 3. So df by dx, which is u dash v minus uv dash over v squared, the quotient rule, is going to equal 2x times 3x minus, well, let's do v dash times u, so 3 times x squared plus 16 all over 3x all squared. And this is going to equal 0 for stationary points. That means the numerator itself is going to equal 0. You can imagine timesing through by 3x all squared if you want, and then this will go. So that leaves 6x squared minus 3x squared minus 48 is equal to 0. So 3x squared is going to equal 48. X squared is going to equal 16. X is plus or minus 4. And the maximum is clearly appearing when x is negative. Therefore, a is going to be minus 4. And this here would be 4. Then I just need to substitute that back into here, which will give 16 plus 16 all over minus 12. So 32 over minus 12. 4 goes into both of these, so 8 divided by minus 3, or minus 8 over 3. And that's going to be my value for b. Just if I put in 4 instead, I would get 32 over 12, so I'd get 8 over 3. Just going to add that. I mean, it doesn't ask for it, but it feels quite useful to write the minimum down, the coordinates as well. Okay, moving on, we've got a very similar function. It's actually the same things in terms of x. G of x is going to equal x squared plus 16 over 3x. But now there's a restricted domain. In fact, it's between a and 0. So remember, we just showed that little a was minus 4. And so I'm getting rid of these values and these as well. So that's going to be my g of x. Write down the range of g. Okay, let's take a look at the graph. Well, we can see, now remember, a was minus 4 minus 8 over 3. So I can get minus 8 over 3 and then any negative value less than that because there's an asymptote here. So g of x less than or equal to minus 8 over 3. On the same axes, sketch our function. Well, okay, I've kind of taken it from the question, but this is what it would look like. And its inverse. So I've got minus 4 and minus 8 over 3. The inverse swaps the mapping around. So, and we get a reflection in y equals x. So now minus 8 over 3 will map on to minus 4. Remember, this is about this is minus 2 and 2/3. So I'll put it here. It doesn't look like the axes are to scale, so then minus will probably be around here. So I'm just going to outline in red the original function just to make it really clear. Let me try again. Okay, and then they're going to intersect actually at y equals x. So it's going to look a little bit like that. Okay, so I just need to bring that -4 down to make it in line. So as long as the rough shape is correct and you've got this sort of thing going on, then you'll be okay, and you get an extra bonus mark if you write these values down like I have. Find an expression for the inverse and state the domain of the inverse. Well, the domain of the inverse is the same as the range of the original function, just with an x in there. So x is going to be less than or equal to -8/3. We can do that without even calculating the inverse. Okay, so just going to clarify that is the domain of the inverse. Right, now for d, I've got that y is equal to x squared plus 16 over 3x, so I need to make x the subject. I can multiply through, so it's 3xy is equal to x squared plus 16. It's a little bit awkward because I've got a quadratic in x here. So x squared minus 3yx plus 16 is going to equal 0. And now I've got a quadratic in x. My a is equal, I don't know why I'm putting that there actually, my a is equal to 1, my b is equal to -3, not -3, -3y. And c is going to equal 16. Therefore, x is going to equal minus b, is 3y, plus or minus b squared, which is 9y squared, minus 4 times 1 times 16, so that's -64, all square rooted, all over 2. Now we've got a plus and a minus, but for our values, there's never any positives. So I'm going to reject the positive. That would be if I'd taken this part of the curve, then it would be the inverse of that. But remember, we have to have a one-to-one function, and this part of finding the inverse does not account for that, which means finally that the inverse function, I just need to now swap the y's back into x's because we've mapped x onto y, but when we actually write down the inverse, we then use x as the input again. So it's going to be 3x minus the square root of 9x squared minus 64 all over 2. Okay, that was part D. So finally, E, solve the equation g of x equals the inverse. Well, as I've already pointed out, they actually intersect also with y equals x. So rather than having this involved and setting it equal to x squared plus 16 over 3x, we can go straight for x squared plus 16 over 3x equal to x. Okay, that is a much simpler way to do it. So then x squared plus 16 is going to equal 3x squared, which means 2x squared is 16, x squared is equal to 8, x is equal to plus or minus root 8. But again, reject the positive, because we can see from our graph it's negative. And therefore, finally, x equals minus root 8. Brilliant.